Welcome here in the Karlsruhe Research Factory. My name is Julius Pommer. I am the maintainer of the open62541 project, and I'm the head of a department here at Fraunhofer IUSB. The name of the department is Cognitive Industrial Systems, and we are situated here in the Karlsruhe Research Factory. But today we will talk about some particular technology that is being developed in the department, the open62541 open source project. And more particular, I will talk about the role of this project in the overall OPC UA technology landscape. The agenda for today is as follows. First of all, I will bring a small recap why OPC UA and why open62541. So some of you might have heard already quite a lot on this, but this is just to give a short reminder for those who are dropping in just for this video. And then to the main body of the talk, our role in the OPC UA technology landscape, how the open62541 project understands its own purpose. Why OPC UA? So as you all know, there are many competing historical protocols in production environments, so both for real-time communication, but also for everything in the upper layers of the automation pyramid. And OPC UA started to unify and to bring a common language to the automation world. And this has largely succeeded in the upper layers of the automation pyramid. And now more and more efforts are also being made for real-time communication using OPC UA, in particular OPC UA PubSub. And what is OPC UA? So to me, there are three perspectives. First of all, OPC UA is a protocol. And traditionally a client-server protocol, and with different message encodings, binary, JS, and XML, and also different transport substrates, TCP/IP, WebSockets, HTTPS, etc. The second perspective is that OPC UA is an object broker, and those of you who experienced the 90s might recall CORBA. And to me, OPC UA is a little bit CORBA done right. So object orientation has a lot of advantages, in particular for information modeling, and we can standardize object types, or you would say classes in languages like Java, that then allow interoperability between different implementations of this object type. And last but not least, OPC UA is a graph database because everything that is described in an OPC UA information model, it can be introspected. We can explore the information model at runtime. And so all these objects and their children and relations and type instance indications, etc., all of these can be explored by taking on this view on OPC UA as making a graph database available over the network. So what is open62541? Well, it's an open source implementation of the ISO standard. OPC UA is developed by the OPC Foundation since many years, but it is also available as the ISO standard 62541. And as you can see on the right-hand side of this slide, we are proud to be an open source project and to be available on GitHub and to invite people to participate in it. So we provide an open source OPC UA SDK. So this is not only the core stack for communication, but on top of that, we provide server, client, and PubSub implementations. And the library is written in platform independent C. So we are available for basically all platforms, Linux, Windows, Mac OS, but also a couple of embedded. And you can use this source code directly off GitHub. But we have an additional distribution mode, which is to amalgamate the entire source code into a pair of .c and .h files. And this is something that can be easily dropped into any project for integration if you have some exotic build environment for your embedded platforms. The project is licensed under the Mozilla public license. That means you can mix the open62541 source code with your private extensions. And there is no leaking of the license conditions, meaning you can keep your private code also private going forward. You only have to make sure that the MPL, it works with respect to individual files. So if you have private code, you should keep that in separate files, but you are allowed to link it together with the library into a static binding. And most important, besides this entire code that exists, there is now a large community and a consistent development over time. So you can expect this development and the support to continue also in the future. Why open62541? Why on earth has this started originally, and why do people still invest considerable amounts of time and resources into this open source implementation? So the library was started back in 2013, and we were all, let's say, a bunch of PhD students, all from German research institutes. And so the original founder was the ACPLT chair at the University of Aachen. But very soon, additional players came in and contributed code. And we were like the nucleus, the starting point of the community. And on the picture up there, you see a user meeting that we had in 2015. And you can see that then already we had quite a lot of interest in the technology and also people participating and contributing. And so today, 8 years later, there is still a lot of interest. And we now have more than 8,500 commits coming from 220 individual contributors, meaning a lot of people and a lot of organizations are using the library and are also contributing back and improving this to have a infrastructure, software, some base technology that can be jointly used for the betterment of the entire automation world. We are breaking all the rules. We are not doing this by choice, but some of the rules that are typically given to new software developers, we have to break. And for example, one of the rules is don't roll your own cryptographic implementations. Well, of course, we use base libraries like OpenSSL or Embed TLS, but still we also have to dig deep into cryptographic code because we are implementing a protocol that heavily relies on cryptographic security for communication. The second thing that we tell developers is don't roll your own database. Use an existing database and your life will be much easier. Yeah, but OPC UA is a graph database if we take on this perspective, and hence if we provide this SDK with minimal external dependencies, then we also have to include many features that originally could be found in a database, so we have to roll our own essentially. Don't expose systems to the internet. Bad things can happen if you expose your system to the internet. Well, this is the idea. So maybe not the internet, but at least to internal networks, we definitely want to expose the library in order to enable communication. And yes, we can have firewalls, etc., and intrusion detection, but also the code quality has to be really good so that we can have trust that the systems will not break and will not provide attack vectors to people coming from the outside. Regularly update and maintain your deployed system. Well, ideally we would like to do so, but sometimes when hardware is deployed, it gets really difficult to send updates. So over-the-air updates are more and more common, but there are also systems in the field now running open62541 where updates are really difficult because there is no direct physical access to the original vendor. And that means in order to provide software under such circumstances, we cannot roll out beta software and hope to patch it later, but the stable releases that we put out have to be solid, and we have to use a lot of tools and also processes to ensure the code quality. And last but not least, don't write software in C. Well, yes, there is other technology. We can use Rust, we can use Ada, or we can use managed languages like C#, but C still has its importance for embedded targets, but also when it comes to dynamic languages that, for example, want to have bindings to a fast implementation. Oftentimes C is then the lingua franca to have the API for the binary interfaces to then scripting languages, for example, C. So how is open62541 used? So it started in 2013 and it grew a lot since then. So if we look at the numbers, we have quite a lot of download numbers, but also additional Git clones and package managers distributing the library as a binary. So we don't actually have exact numbers on the downloads because there are now various sources like the package managers. But in surveys, we are coming out quite nicely. So from the BSI, so the German Office for Information Security, the Federal Office for Information Security, they put out a survey on OPC UA, and we came out at nearly 18% of market penetration last year. And so industry is using this for prototyping to get their feet wet with the technology, but also more and more for actual product development. And besides the industry side, there is research. And if you look at Google Scholar, some days ago, we were at over 250 papers that were using, or at least mentioning, open62541. So also a lot of, well, prototyping and proof of concepts for in the automation world are making good use of open62541. We have language bindings, a couple of them sitting on top of our core library. We are part of the standardization, for example, in the FLC, the field level communication group within the OPC Foundation, or for standardization efforts like UMATI. And besides classical production automation, OPC UA is also more and more used, for example, in large-scale physics experiments that are using automation technology to drive their experiments. Examples that I can name here are the Large Hadron Collider near Geneva and the particle accelerator Elbe near Dresden. And a couple of additional large-scale physics experiments are also well, integrating more and more of the traditional automation technology and then using OPC UA for communication and control of the data streams and the experiments. And last but not least, it's an open source project. So we are very happy to have now 2,000 stars on GitHub. I know this is a vanity metric, but still it shows the success and how many people are interested and want to receive regular updates coming from our repository. So our role as the implementation in C is of course different from all the other implementations that use Java or that use C#. So we aim for embedded targets and upwards. And depending on the features that you configure, we can get down to 200 kilobytes of ROM and RAM. So the information model in the server obviously has a big impact there, but we are already experimenting with a ROM-based information model. That's work in progress, but looking quite promising to even reduce the RAM consumption quite more. And this is something that typically you can only achieve by using C. I'm not talking about assembly. And this is a distinction that we have compared to other open source SDKs. Of course, there are commercial SDKs. There are also commercial SDKs for the embedded space. And we will come to some distinctions with respect to them later on. But I think from the numbers, we are looking quite good. And particularly, I want to highlight that OPC UA sounds like a very complicated and big standard, but for our implementation, which is getting closer and closer to feature complete, it's actually not so much code. So a lot of the code is auto-generated, and for the code that is written by hand, if you look at the statistics here, for example, the server on top of the stack, it's about 16,000 lines of code. So quite manageable, but of course code that was really hard gained and a lot of effort was put into reducing the code to this level where it is readable and featureful. Our role is to be also the gateway drug to OPC UA. So somehow people have to get started with OPC UA. And so back in 2013 when we started, it was quite a big hurdle to get into OPC UA initially. And with open62541, it's easy. You can download the source code and you can get started on the tutorials within a couple of minutes. And that's also the best way to counter arguments. So back then in the automation world, there was a lot of fear, uncertainty, and doubt. So OPC UA is complicated or it's not efficient, etc. And now we have the best argument that is, which is try it out on your own and see how it works. And so make the hurdles to entry so low that OPC UA in general is considered by more developers whether they then finally choose an open source SDK or a commercial one, but just to bring OPC UA to the developers, have them have a look at it, and hopefully fall in love. So, and it's a full SDK that we provide. So you can develop full servers and clients with minimal effort. In other places, you get the stack, but you have to implement most of what the server provides, which are the services, the 37 core services. You have to implement them on your own. And here you only have to add information to the information model. But once the information model is done and potentially some callbacks to underlying devices, then you don't have to implement the OPC UA services on them. And very important, open62541 comes with no strings attached. I already spoke about the Mozilla public license, so you can combine private developments with the core library, and you don't have to make your own code public, with the exception that if you make changes to the core library itself, then these changes that are in the same files as the core library, they also fall under the entity. And what happens sometimes is that there are dual licensing efforts, meaning that the code is available under an open source license, but also under a commercial license, which brings the possibility that in the future somebody decides to switch the licensing model and to no longer deliver updates as open source, etc., etc. So this fear is not founded for open62541, because there is no single entity that holds the copyright that could change the licensing model in the future. So all the developers, more than 220 that have contributed to the repository, they still retain their copyright. And so now there is no single entity that could switch the licensing model. So by that reasoning, OPC UA will be available in the long term. So suppose that 10 years from now, you have a product that was delivered today in the market, and suddenly OPC UA deprecates some security policy or adds a new security policy, and you are asked to take the product version that was delivered today in 2022 and to make changes to the security policies that are provided. Now, let's say you have to add a new security policy with some new cryptographic algorithms. How confident are you that the SDK that you're using will still receive these updates 10 years from now? And do you have the technical means and also the legal right to make such changes on your own if this is required? So do you have access to the source code? Are you legally allowed to make changes to the source code? Do you have the right development set up, compiler, etc., etc., to 10 years from today make some pretty fundamental changes to an open source, to the OPC UA SDK that you're doing? With open62541, you can expect that will be possible. First of all, we have achieved critical mass for the project to stay around for a long time. And you can see that the development was pretty consistent over the last 8 or 9 years. And so with now more and more users, it is to expect that this will not fall short going forward. And if need is, you can even take the code from today and make some changes to that on your own if 10 years from now you have the need. So this possibility is now open to companies and developers. And what also happens in some cases is that open62541 is the fallback solution. So if something would happen to another SDK, then there is a fallback solution that can be deployed quite fastly. So companies using a second source strategy overall. And now you see that there was this stable development over the last 10 years. And there are always things that can be worked at, that can be improved, etc. But what is important to us is that the core SDK converges to a stable implementation. So the ISO standard for the client-server OPC UA protocol is still improving, but is improving in backwards compatible ways. So it's also, there are no drastic changes over time. And the way we have architected our software the core library, which is independent from platform-specific differences, can now converge to a stable implementation. And this is exactly what we are now seeing in many aspects of the SDK, that that we are going into a maintenance mode, but where the functionality is feature complete with respect to what the standard describes. So besides providing the code, the community is very important, so that the people contributing achieve more than just the sum of their parts. So we and the entire team, we go into the lead for development and for maintenance of many features, but we couldn't develop the SDK alone, by far not. So we rely on the entire community participating, people who contribute sometimes code, bug fixes, but very importantly also bug reports or the result for testing against another SDK, documentation improvements, helping out in the GitHub, issue tracker on the mailing list, etc., etc. And we have gone so far to say that also commercial support should not only come from Fraunhofer USB. In some cases, we do provide commercial support, but we are not the best fit for each case. And so now there's a range of different companies that are active and that are providing commercial support surrounding the SDK. And for those who have a commercial offering and who are also members of the community in good standing that contribute code, etc., etc., we list them on the homepage to get them also visible to potential customers. And so I can mention here a few. Calicito, Basiscom, Linotronics, but also Rosade. Rosade is not a commercial support provider, but they play also an important role in the automation community when it comes to dissemination, communication, getting the message out, and obviously organizing the letter of intent projects, as you are also participating. The role of open62541 further is to provide insights into the inner working of OPC UA. So to not say, well, this is a very big and opaque and complicated standard, but to explain to people that OPC UA consists of many, well, internally consistent, logical, technical solutions, and that are nicely fitting together. So how the data type model of OPC UA ties into the entire protocol of what messages and what content can be exchanged, or how the 37 core services that exist in OPC UA are enough to enable a wide range of use cases, etc. And so to provide this insight into the inner working, we have quite comprehensive documentation, but also the code itself is our documentation. So the code is, in comparison to the provided features, quite short. And we aim for, and we I think have achieved clean code where the heritages are well documented and where we have a very nice one-to-one mapping of the abstractions described in the standard to structures and data types in the implementation. So all of this can be used, for example, to print out the OPC UA standards and to have in parallel a look of the open62541 code and then see how this corresponds. And oftentimes we are surprised by how few lines of code we were able to implement a certain feature that takes then a couple of paragraphs in the standard to describe. And obviously, in order to achieve readable code, it must not only be short, it should also not be obfuscated too much. And so we are measuring, for example, the cyclomatic complexity. And here are some of the worst offenders in the core stack. And so if these are the worst offenders, then I think we are quite okay when it comes to code complexity. And to end this, our role is also to allow research and proof of concepts for extending the standard itself. And there are a couple of examples from the past that I can point to. So even some examples where a change that was originally prototyped with open62541 eventually ended up in the standard, like sessionless services, where there was a nice publication in 2016. Furthermore, we are used actively in the FLC for prototyping of certain PubSub features. and a couple of the less explored parts of OPC UA, like the global discovery server or the SKS key distribution for PubSub. There are development efforts in progress right now to develop this, and which also leads to an interaction and feedback to the developers of the standard for things that are maybe under-specified or where we have the need for clarification. An example that is ongoing right now, you might not know that for event filters, there's entire query and filter system embedded in OPC UA, a little bit hidden, and we are working on a query language, for example, to expose some of the less used features of OPC UA to a wider public by making them more easy to use. And we want to be good citizens, good participants in the OPC UA ecosystem and the foundation overall. Hence, we participate where we can in the Mantis bug tracker, in certain working groups. We are not present there all the time, but we are have contributed, for example, to the security and PubSub working groups. We interact with the certification lab. There is now the next certification level of the open62541 SDK ongoing, and participate in the interoperability workshop, where by now there are always some people with open62541 present, either from Fraunhofer or from other organizations. And with that, what remains is to thank you for the attention. So this is a pre-recorded video, but I'm happy to also take questions now in the live engage. Thank you.